Now see, in this question it is given that like there is a variable line. Let's draw this. There is a variable line. Suppose this is a variable line. It is intersecting n lines of the type y equals to x, y equals to 2x, 3x, goes on till y equal to nx. So all these are the lines which are passing through origin and intersecting these lines in points a1. So this is intersecting in a1, this is intersecting in a2, a3. In general, y equal to nx is intersecting in an. Like for example, y equal to x, y equals to 2x, 3x. So this point is a1, line is y equals to x, point is a1, line is y equals to 2x, point is a2. Now what we need to show is this variable line, and I forgot to mention this condition is given that sigma of 1 by OA P. So it is given that the line is represented as y equal to px. So we can represent these lines in general as y equal to px. So it is given that summation of 1 by OAP square, p varies from 1 to n, is c. So basically 1 by OA, this distance, plus 1 by OA1, OA2, goes on till 1 by OAN equals to constant c. C is constant. So basically I measure, this is O point, this is A1 point. I measure this distance OA1 and take reciprocal. I measure this distance OA2, take reciprocal. So sum of distances between OA1, OA2, sum of the reciprocal of the distances between origin and points of intersection is constant. And we are supposed to show this line, this variable line always passes through a fixed point, right? This variable line always passes through a fixed point. So what we can do, we can first of all we can solve y equal to a general representation. We can take y instead of px, I'll prefer to take y equal to mx. So m represents slope better than p. So y equals to mx, I'll solve y equal to mx with this variable line whose equation I can assume as ax plus by equals to 1. So the other ways to assume, you can assume y equal to mx plus c, but I won't recommend you assume it like this in terms of 3 variables. Just use 2 variables, not 3 variables, to represent equation of this line, because we have to show it passes through a fixed point. So it's advantage, it would be advantageous to use less number of variables. So we use either a and b or m and c. So let's take this because this is what is given in the module. Now we solve these two. We replace y equal to mx to get x and then replace x to get m. So coordinates of this point, general point OA, AM, we are solving with y equal to mx. So AM is x coordinate is 1 over a plus bm, comma m over a plus bm. Right now, if we can find OM now. OM is distance of the same point from origin, right? So we can apply apply distance formula. Right, so if you apply distance formula, we'll get 1 by a plus bm square plus m square over a plus bm square square root. So 1 by OM, take the reciprocal of this to get we take the reciprocal of this to get mod of a plus bm. In the numerator, mod will come because we are taking square root of a positive of a perfect square. So it is mod of x. divided by root of 1 plus m square, and this is given equals to constant c. So we can write this as a plus bm, sorry, this is not c, summation of this, summation of a plus bm divided by root of 1 plus m square equals to c. Mod is also there. We can remove mod sign and put plus minus. Say plus minus, we shift here. M varies from 1 to n. Now this is the condition we have derived. Now we have to show this line ax plus by equal to 1 passes through a fixed point, that there is a point through which it will always pass. Now this question, see, generally in this question it's easy, because if you look at this expression, I have to take sigma over m, not a and b are constants with respect to m. So I divide about this plus sign into two parts, shift a out, it becomes sigma of 1 by root of 1 plus m square. M varies from 1 to n. Then b, summation of m over root of 1 plus m square. This is constant, say capital C. Plus minus c I replace by capital C. Now you can see, if you and I can divide by c, I can make this 1, I can divide by c. Now you can see this is this point, this is the, and this is not going to change, this is fixed, there's nothing changing here, the sigma will always be fixed, right? Because c is fixed, c is constant, so this is just a number. So this is the point, x coordinate is this and y coordinate is this, through which this ax plus by plus equal to 1 line will always pass. So if I replace this as ax naught by naught equal to 1, this implies x naught y naught is a fixed point through which line would always pass. Another approach could have been, from here we would have got the value of a, right? If we solve this to get the value of a and replace here, replace in the equation of the line. In terms of b, replacing in terms of b, suppose fb into x plus b into y equal to 1, and then the next step would have been combining terms of b on one side and rest of the term on the other side. So we would have expressed this like this as a family of lines. There's another approach. We have two variables, we eliminate one variable in the equation of a line, either a or b, using this condition. And once we have one variable, we express it like this: variable on one side, all other on this side. Now from this we would have said this represents the equation of family of lines passing through a fixed point. So for all values of b, this would always pass through a fixed point. You know, a and b are changing because this line is variable, but whatever values b takes, this will always through a fixed point, that is intersection of L1 and L2. But in this question there is no need to do this, because we could exactly find the point through which the variable line is passing.